In this video, I'm going to walk you guys through some more intense factoring, I guess is what you'd call it. Our goal is to find the horizontal and the vertical intercepts of these two functions, but they're a little bit more involved with the factoring, so it's a good examples to look at. Now, I did change this example, so check your paper and make sure that yours matches mine. It's 4x to the 5th minus 16x to the 4th plus 16x cubed. But I'm going to use a bigger piece of paper so you'll be able to see everything a little bit easier. All right. By now you should know that horizontal intercepts are found by setting the equation equal to 0. So our output is 0 and we want to solve this equation, find all x values for it. All right, like I said, we're going to do this by factoring, and so let's do our GCF factoring first. And when you look at these, the only thing that's going to be common in both is the x squared. So as we take x squared out, let's think about what we still have left, which is if there were 6 of those in there, 6 factors, we pulled out 2, we're going to have x to the 4th, and the only thing here is a 16. Okay, now that's all good, but now we have this quartic with that 4th degree in there. And this is something you may have run into as you've done your Delta Math homework. When you have a 4th degree and a 16, which by the way is a perfect square, you can do some factoring patterns called the conjugates, where we're going to split this up. X to the 4th we're going to split in half. So we're going to put half of our factors here and half of our factors here, and that's our x squareds. And then the perfect square we have here is 16, which means it was 4 and 4. So 4 and 4 will finish off the other ones with one being positive, one being negative, a factor conjugation. Don't lose that x squared though, I almost did. Okay, now there's what we call here a sum of squares. Now something that you guys need to remember is that a sum of squares is never going to factor for you. So you can just bring this right down. Don't try to split that up. It won't ever factor. The difference of squares you have here, that's going to factor. You should have some practice with that. So we're going to break this up just similar to what we did up above. We're going to put half of our factors of x in each parenthesis, so x there and x there. 4 is 2 times 2, so a 2 in each spot, and then a plus in one and a minus in the other. So another set of conjugate factors. And still, I keep leaving that x squared behind. Bring that down. Okay, so that sum of squares does not factor. That's the end of that. The difference of squares factors as these conjugates. All right, and now that we're done with that, we get to set each of these equal to 0, one at a time. So x equals 0, or sorry, x squared equals 0 is going to be double multiplicity. X is 0. This one is interesting. We should spend some time here. X squared plus 4 equals 0. Now that means that if we subtract 4 over, we're saying x squared equals negative 4. And your mind should be saying right there, that's impossible. Do we square numbers and ever get negatives? And we don't. But if you keep going, you're going to take a square root of both sides of that, which is positive and negative square root of 4. Square root of negative 4. Positive and negative square root of negative 4. Can you take the square root of a negative number? You never can. So this is an imaginary number, which is something you should have, spell imaginary. Imaginary. It's an imaginary solution, something you learned about in Algebra 2, but it's nothing we're going to deal with as we're looking for roots. We're looking for horizontal intercepts, and those are never imaginary. So no solution for our reals here. All right, moving on to the easier stuff. X equals, that'll be negative 2 for that one, and this one's going to be x equals 2. So my horizontal intercepts are x is 0, so 0, 0. X is negative 2, and x is 2. So each of those in their coordinate form, and this one is multiplicity of 2. Okay, let's tackle the vertical intercept. These are our favorite kind, at least they're mine because they're very easy. Vertical intercept is where we plug in 0. So we just plug it right in. So we're doing g at 0 is going to be 0 to the 6th minus 16 times 0 squared. And last time I checked, all that's 0. So vertical intercept is 0, 0. And these are our answers. Okay, and there's a second one. I hope you got this second one with the correct equation. Here it is again if you need it. Same story. So let's do the easy one first, should we? Let's do the vertical first. So let's go f at 0, just like we just did on the last example. Plug in 0 into all of that. Just plugging it in. Alright, so I've got a 0 in every single term. That's all going to multiply out and give me nothing. So 0, 0. Answer for that one. Vertical intercept is 0, 0. Okay, now that that's out of the way, I'm going to box that over. Let's take a look at the horizontal intercepts. This is a little more challenging for me. Still, I set the output equal to 0. Just copy the rest down. And now I'm looking for factors. So I always look for that GCF first. This time I think a 4 will come out of all of that. And when you look at the x's, every one of them has at least x cubed. So my GCF is 4x cubed. That comes in front. And what do we have left? The 4 is out. We had 5 factors, we pulled out 3. So x squared, there'll be 2 left. Here, bring down that minus. The 4 is out, leaving another 4. 4 times 4 gives 16. And all the x's but 1, 4x. And here, the 16 is going to become a 4, and the x cubed is pulled out. So we should double check, make sure this is right. 4x cubed times x squared. That's 4x to the 5th. 4x cubed times negative 4x. 4 times negative 4 is 16. X to the 4th. Yeah, 4. And 4 times 4, 16, x cubed is the last. So we're good. But what it leaves us is a factor that's a trinomial. So we need to try to factor that even further. So when you look at that, let's see. If I have a 1 in front, 1 times 4 is 4. And now looking at the middle term, we need to build a negative 4. Factors of 4 that make a negative 4 would be 2 and 2. And they're going to have to both be negative. So negative 2 and negative 2. Now this is the one that has the nice shortcut pattern in it. Did you guys notice that this is a 1? So if that's a 1, I really have my answers right here. I'm going to put an x in each spot, and then I'm going to bring these numbers in to finish the factors. So it's x minus 2 times x minus 2 times 4x cubed. Our GCF is in there. All right, well that's the same factor twice. So this is a multiplicity situation. I'm going to say I've got x minus 2 and it's squared and 4x cubed. Okay, setting all of these equal to 0, one at a time, we'll say 4x cubed equals 0. If we divide by 4, we're going to just say x cubed equals 0. And so x is 0 with multiplicity on it of 3 times 3. And x minus 2 is 0 with multiplicity, which I'll note at the end. So x is going to be 2, multiplicity is 2. Now, we're going to be graphing these a lot. So there's the answer to the question. Well, I guess I should box the answers here. So the horizontal intercepts are 0, 0, and x is 2 will give me a 0. And so there's my answers. Now, that's really answering the question. So this next part is just bonus stuff. I'm going to graph them just so that you guys can see the practice of this, especially because these had multiplicities that were interesting. So if I do a quick sketch of this graph, 0 is on my number line, and so is 2. And the ends of this do a 4x to the 5th end model. So on the ends I've got 4x to the 5th, and I'm thinking which way did those ends go, and those are going to be negative to start and positive when we're done. Okay, so we're going to start down here, but before we make any decisions, let's look at the multiplicity of the 0 there. It's a times 3. That's a cubic root, cubic multiplicity. So as I come from below, I need to make that kind of bend like the cubics do. Make it look like a little cubic graph right there. And then moving on to the 2, that had a multiplicity of 2. So this needs to look like a little parabola. It's not going to cross over. It's a positive, and it's going to be coming up like this. So that's going to be good because I need to end up. The end is up here. And I can kind of sketch a little bit of what that graph would look like. So if that's good, let's go back to the other example. Let's see what the graph of this one looks like. That imaginary number is not going to show up as we do our rough sketch of our graph. What we need to do is pull these intercepts on. All right, so -2 was one of our intercepts, and +2, and 0 in the middle of those. And 0 has multiplicity of 2. So let's check our ends. It's an x cubed. Thinking about what the ends of the x cubed graph looks like, I'm going to say they're up or positive to start, and they're positive when they're done. Okay, so end is up. It's positive. This was a normal root. This was the double multiplicity, 0. But over here, this was the normal single multiplicity. So that's going to go through. Then down here, it's going to come from below and make a parabola turn right there at 0. And then it's going to come from below and end up here. So you can kind of connect it all. So our graph should look something like that. All right, that does it.